Here we have three volcanoes, which is composite volcano, cinder cone volcano, and shield volcano. Now the general safety precautions for these volcanoes, or any volcano, is to first listen to instructions from your government, and if the water level in that area or whatever area you are in rises, you should really move to higher ground, and if mud flow is coming or passes a bridge, you stay away from that bridge. You should stay out from restricted zones specified by government officials, and avoid river valleys and low-lying areas. You should close all doors, windows, or any openings around your house, and you should turn off all electronic systems, and if there's a rock fall, you should really roll into a ball to protect your head. If you're in any contact with volcanic gases, you should move away from that immediately, since those gases can affect you a lot. And you should wear long clothing to protect your limbs, like legs, feet, head. You should use goggles to protect your eyes, since those gases can hurt your eyes a lot, and ash can collapse on homes, so you should try to evacuate as soon as possible. And you should keep your car engines turned off. You should not drive during ash falls, because that's really dangerous, driving during those. And you should really have an emergency supply kit, such as food, water, radio, flashlight, and other emergency stuff.
Okay, so after hearing about the safety, we want to hear about the dangers. And so these are one of the many few dangers that appear or happen during a volcano. There is a pyroclastic density currents, which is technically just a flow and surges of hot gas and rock. It's pretty much magma, if you want to call it, but it's just very fast. And it can create a bunch of sulfur and ashes that go along the way. And so it can also create a lahar, or however you pronounce it. It's an Indonesian term that describes hot or cold rock fragments flowing down from the slopes of a volcano or river. And there are also structural collapses or debris flow avalanches. And because, the magma can burn and take down structures such as like buildings, because it can melt it easily after it's really hot lava, as you can see. And there are also dome collapses in the form of pyroclastic flows and surges. There are lava flows, obviously, tephra falls, and ballistic projectiles, volcanic gas, which can also hurt your eyes, like Fahin said. Tsunamis can occur from earthquakes, which happen to volcanoes, and volcanic lightning.
Here we have cinder cone volcano, and cinder cone volcanoes are built from particles and blobs of congealed lava, and that are ejected from a single vent. As the gas-charged lava is blown violently into the air, it breaks into small fragments that solidify and fall as cinders around the vent to form circular or oval cones. That's why it has the name the cinder cone volcano. Shield volcanoes are formed by lava flows of low viscosity and easily. With shield volcanoes, lava flows easily for many kilometers, and because of that, it creates gently sloping slides. In this case, our shield volcano is not that gently, but in a real-life scenario, it would be, because of how easily the lava flows. Predictions of volcanic eruptions. There are warnings before a volcanic erupts, so you should really listen to those. And there's hundreds of small earthquakes are caused as magma rises up through the cracks in the Earth's crust. Seismometers are used to detect these earthquakes. Temperatures around the volcano start to rise as the activity increases, and the temperature around that gets really high. And when a volcano is close to erupting, it releases gases, and they're really noticeable. And the higher the sulfur content of these gases, the closer the volcano is to erupting, and the gas samples may be taken to measure the sulfur content. Thermal images or sensors are used to detect the amount of heat around the volcano. And before a volcano erupts, magma or molten rock rises towards the surface. Here we have the epicenter. An epicenter is the point on the Earth's surface vertically above the focus of an earthquake. An S-wave, or short for shear wave, is a seismic body wave that shakes the ground back and forth perpendicular to the direction the wave is moving. A T-wave, or P-wave, commonly known as, are a type of body wave that is the first wave to arrive at the seismograph. It's called seismic waves in seismology. It can travel through a continuum, and the continuum is made up of gases, as sound waves, and liquids or solids, including on the Earth. P waves can be produced by earthquakes and recorded by seismographs as well. And the Richter scale is the measure of an earthquake. Now the Richter scale is used for measuring earthquakes, and it starts from 2 to 9. 2 is least, and 9 is the highest or greatest point of the earthquakes. Now 2 is micro earthquakes, which is like not felt or like very rarely felt by sensitive people, and recorded by seismographs. Now 9 is a near or a total destruction of severe damage or collapse to all buildings, or all buildings that comes through the earthquake's way. And it brings heavy damage and shakeable extent. The shakes extends distant locations and permanent changes in ground topography. Safety precautions for earthquakes are to listen for instructions from your government, and before an earthquake happens, you should research your area and see if you live near an active fault line, and reinforce your home if you're in a high-risk area. Now you should create a disaster plan for you and your family, and to know where to take cover in your home. You should put together an emergency kit, have plenty of food, water, flashlight, medicine, and other emergency needs. You should stay away from windows and furniture that could fall over, and take cover in a safe place in your home. Do not try and go outside after the shake stops, because there are aftershocks, and you should be prepared of those aftershocks. Now, predicting earthquakes are used by laser beams that can be used to detect plate movement. A seismometer is used to pick up the vibrations of the earth crusts. Radon gas escapes from the cracks in the earth's crust, and since radon gas escapes, you can use that as predicting earthquakes. And studying how fast strain accumulates, and that is plate movements build a strain in rocks to a critical level, and that can be studied to measure or predict earthquakes. The dangers of the earthquakes are ground displacement, falling debris such as buildings, wood, concrete, glass, and other things, potential tsunamis since earthquakes can cause them, landslides and rock falls. Liquefaction is when soil turns into liquid and sinks in, and floods, such as the earthquakes can cause the dam walls to break, which cause the floods, and falling electric lines, such as electric lines and poles that can fall over because of the earthquakes and could cause major fires. Now, if you've learned the dangers, predictions, and measurements of the earthquakes and volcanoes, it will be very useful in the near future.